Ratio calculations. Right, now we'll begin with two fairly easy ones, and we'll follow up with a couple more challenging questions. The first one, a square has a side length of 2.4 centimetres. If the side length is trebled, the ratio of the area of the original square to the area of the larger square is, right, well, just see if you can do this one yourself. It's quite an easy way of doing this, but I'll go through the slower way. Take the side 1 to side 2. Now it's going to be 2.4 and 2, and when multiply this by 3, we get 7.2. The areas, because they're squares, area 1 to area 2, is simply 2.4 squared as to 7.2 squared. And that breaks down, works out as 5.76 to 51.84. But when you break this down, divide that one into that one, you get the ratio 1 as to 9. Now we didn't have to go through all that, because it was an area of a square, and we had 1 by 1, and we made that 3 by 3, then the ratio is going to be 1 to 9. Right. Number 2, in a particular school, ratio of boys to girls is 4 to 5. The total population is 1,080. How many boys attend the school? Well, if we add these parts together, it's a total of 9 parts. So 9 parts represents 1,080. And we divide that divide that by 9, we get 1 part is equal to 120. But there's 4 parts of boys, so 4 parts must give me 4 times 120, so there were 480 boys there. Right, now for the next couple. Number 3, this is the harder one. There are a total of 119 balls. The ratio of the number of red, let's do that, make that a red here, red to green is 1 to 3. And the ratio of the number of green to blue is this ratio. So to set those up, we're going to say red to green equals 1 to 3. And then we're going to say green to blue is equal to 2 to 3. So notice there's the green here and the green there. So what I'm going to do is I'm going to make these numbers the same. Now to do that, I'm going to multiply this ratio here by 2 first. So that then becomes 2 to 6. And to match this one up with that one, I'm going to multiply both these by 3, because you're not changing the ratio. So it simply comes, when I multiply that by 3, it becomes 6. And I multiply that by 3, I get 9. So now I can safely say that the red to the green to the blue is equal to 2 to 6 to 9. The total number of parts here, when you add those up, is going to be 17. So 17 parts must equal, where was it? Here we go, 119. So 1 part equals 119 divided by 7. And I think that comes out to, 17. It comes out to 7. And therefore, 2 parts, because that was the number of the ratio here for the red, over here, oops. Yeah. So 2 parts will equal 2 times 7. So there must have been 14 reds. Okay. Now we'll move on to the next one, number 4, which is again quite a challenging one. Right, number 4, a bit more of a challenge, this one. Right, we have 200 ml of water, and chlorine contains 8% chlorine. How much water needs to be added to reduce the chlorine to 2%? First of all, we'll work out how much chlorine we've got in the mixture. So we've got 8% of 200 ml. multiplying it together, we're going to get 16 mil. Now we've got 92% of the water, so it's 92% of the 200 mil, gives me 184. These two will add to 200, like you're just taking it away from the 200. Right, now I'll let x equal the extra water. Okay, so now if we look at the ratio, we'll say that x, the new added water, plus what we've already got, that must be in the ratio of that to 16 because the chlorine stays the same. But that's also, now it's changed now, the ratio now has changed from 98 to 2. That's the 2%. Right, now as a little equation, we've got x plus 184 divided by 16 is 98 over 2, which is 49. X plus 184 equals 49 times 16. So x plus 184 and 49 times 16 is 784. And when we subtract that from that, we get the result of 600 mils must be added. Okay, it's done.